Hello there, ladies and gentlemen. So, welcome to another video with Dyson, the sphere. So, do you know Albert Einstein's theory of relativity? It basically says that the universe has an invisible four-dimensional cloth called space-time, acting as the backbone of the universe, and also that this same fabric, which is again space-time, is the connection between space, everything we can see and touch, and time, a mystery of which nobody knows the reason of. But have you ever wondered how space and time interact with each other? So let me introduce you to time dilation, or the only known method of time travel. So let's go back to the future. So this video is gonna be confusing for you or pretty much anybody else in existence who is not a very big sciencey person. So first you need to understand there are two types of time dilation. Yeah. So they are the velocity time dilation and the gravity time dilation. The VTD and the GTD for short. So I am mainly going to explain both of these types using an example. So let's start with our velocity time dilation or the VTD. So for this, let's take two twins. I randomly named them chocolate and candy because why not? I am a literal Dyson sphere around a star. So both of them are 10 years old when Candy is sent into space. So in space he is made to orbit the earth at 99.999% the speed of light. If you did not understand exactly, he was put in a spacecraft where and the spacecraft would orbit the earth at 99 very close to the speed of light. Meanwhile, our other man, Chocolate, is still there on earth dancing. So when Candy was 15 years old, he was sent back to earth. So for Candy, 5 years had passed, he was sent back to earth again. So you might expect Chocolate as well to be 15 when Candy returns. But no, he isn't. Because my man Chocolate is still not even 11 years old. Let alone being 15 by like Candy. So Chocolate is not even 11 years. He's still around in the middle between 10 and 11 years. So this is a classic example of the twin paradox. So this paradox this example just quickly tells that the closer to the speed of light, the slower the time feels for the person going at the speed. Yeah. So and also this is also an exponential curve. So as you can see in the bar graph, just the graph given here. So next is GTD or the gravitational time dilation. So here we're going to take two planets, Chonia and Francisco, because why not? They are created by me. They do not exist in real life, but why not? So Chonia is a planet orbiting far from its star and is also less massive than Pluto itself. While Francisco is a Jupiter-sized giant, a very massive giant at that, orbiting very uncomfortably close to its orbital parent. Not too close to be engulfed by it, but close enough to rotate it. And this orbital parent is not a star but a literal black hole. Yes, it's true. It does not exist, but just this is for this example. So the black hole is approximately 1 million solar masses. So we have sent two other twins, not Chocolate and Candy, but Ban and Can. Cause why not? To Chonia and Francisco respectively. Ban to Chonia, the small one, and Can to Francisco, the large one. So both of them were 10 when they were sent to their respective planets. After Can became 15, in Can's perspective, so both twins were sent back to Earth. So guess how old Ban would be? He would approximately be 10, not even a month older. Yes. So meanwhile, our man Can would enjoy in San Francisco for about 5 years. Band would only enjoy Antonia for less than a month. Yeah. So this also shows that the higher the gravity, the slower the time, and this could also be an exponential curve. But these examples are very big and unrealistic circumstances. But there actually have been real life examples of time dilation happening. So now let me introduce you to the Heffel-Keating experiment. In 1971, there are two scientists, just partners like that, Joseph C. Heffel and Richard E. Keating. So they conducted an experiment with atomic clocks flown around the world on commercial airliners. And if you don't know, atomic clocks are very, very accurate clocks. They can measure time periods as small as 9 billionths of a second. Yes. So I'm going to explain this in a later video about this strontium slash atomic clocks. So meanwhile, let's just continue on this example. So they observed that the clocks aboard the planes which were traveling at high speeds experienced a small but measurable time dilation effect compared to those stationary clocks on the ground. So you see, there were clocks in the airplane and clocks just on the ground. So there was a very small but still measurable time difference between both of them. Even if it is not in seconds, nor milliseconds, nor even nanoseconds, yeah, they still measured it somehow. It is still small. That means it does happen. The time dilation does happen, not just in very extreme circumstances, but in normal circumstances as well. So basically, this experiment just shows that time dilation does even happen on a plane, but it is not noticeable by any animal which we know of, any being which we know of. The only way we measure this is using atomic clocks, not even normal house clocks which you have all over your home. So this was the amazing world of time dilation. A very confusing but still very easy thing to understand. It's not that hard. It just says that time travel is very much kind of possible. And this same time dilation is also shown in Christopher Nolan's cinema, The Interstellar. Yes, when they go to Miller's planet, they state that for every 1 hour there, 7 years happen on Earth. Yes, just watch that movie again. I never watched that movie, but I still know that scene. So that was, as I told before, the amazing world of time dilation. And for now, bye, you puny humans.